Hey guys, and welcome back to this week's video, which is going to be about intermolecular forces, which are the forces between molecules, and in this case between covalent molecules. They're also referred to as IMF because that's just simpler. So there are 3 or 4 main types of intermolecular forces. There are London forces, there are dipole-dipole forces, dipole-induced dipole, and hydrogen bonds. And the ones with a star around them, so London forces, dipole-dipole, and dipole-induced dipole, are also referred to as or grouped together as van der Waals forces. So let's take a look at London forces first, which are also referred to as dispersion forces. So London forces, or dispersion forces, are between non-polar molecules, and it's the weakest type of intermolecular force. So how does this happen? Well, a nonpolar molecule is, in theory, completely neutral, which it is. There's a completely equal distribution of electrons on both sides. However, electrons are always moving, and because of that, we say that at some point there's more electrons towards one side than towards the other. So as the electrons move, for example, more can be found at this chlorine. And this creates an instantaneous dipole where we have a slightly negative charge and a slightly positive charge on either side. Now, this is an instantaneous dipole, but what this also causes is an induced dipole on the neighboring molecule, because if you think about it, if you have a completely neutral molecule next to it, that won't really make sense in theory, because the electrons here will sense the negative charge and will move away from it, creating a slight negative charge here and a slight positive charge here. So the electrons within the neighboring molecule move, and it has an induced dipole. Now we can see that both of the molecules now have slightly positive and slightly negative sides, and the bond between the slightly negative and the slightly positive side is what we call the London force. Now let's move on to dipole-dipole forces, which are stronger than London forces, and they're between polar molecules. Now these are way more simple, and they make a lot of sense, because if you think about it, we start off with an already polar molecule, which already has a slightly negative and a slightly positive charge. And if we have another one of these molecules, we're going to end up having the positive charge adjust and be attracted to the negative side because of the electrostatic attraction between the two, which creates this dipole-dipole force. So this is very simple, but it is stronger because the molecules are already polar and already have the slightly positive and the slightly negative charge. Now the dipole-induced dipole is, you might be already guessing it, is between polar and non-polar molecules, and you might already be guessing how that would work. Is the polar molecule, let's stick to the example of hydrogen chloride, the polar molecule will induce a dipole on the non-polar molecule. So the electrons within the non-polar molecule will move and adjust so it has an induced dipole. And why might this be? Well, if you imagine you have a polar molecule and then you want to have a non-polar molecule, that won't really work because this negative side will repel the electrons and they will move away, which creates a negative side on the other side, and this is our induced dipole. And the attraction between the slightly positive and the slightly negative side of these molecules is now a dipole-induced dipole force. And the strength of this is somewhere in between London forces and dipole-dipole forces because we have both nonpolar and polar molecules. Now, last but not least, let's talk about hydrogen bonds, which are the strongest intermolecular forces that there are between covalent molecules. And this happens when hydrogen bonds with nitrogen, oxygen, or fluorine. So why might that be? Well, this is technically, hydrogen bonds are a special case of dipole-dipole, and they're called hydrogen bonds and are a special case because of this great difference in electronegativity between hydrogen and nitrogen, hydrogen, oxygen, hydrogen, and fluorine. So just for interest, we can see these are the electronegativity values. So the electronegativity difference between nitrogen and hydrogen is 3, the electronegativity difference between oxygen and hydrogen is 3.5, and the electronegativity difference between fluorine and hydrogen is 4. So there's this very stark electronegativity difference in electronegativities between hydrogen and these elements. And a hydrogen bond is very important. You have to remember this, or you have to at least understand this, because a hydrogen bond is not the fact that there is this great electronegativity difference. A hydrogen bond is when you have two molecules that have hydrogen and nitrogen, oxygen, and fluorine bonded, is a bond between such of those two molecules. So let's see what I mean. Let's say you have hydrogen fluoride and let's say you have hydrogen fluoride again. The hydrogen bond is the bond between the two molecules that have hydrogen and fluoride. It's not a bond within the molecule. Remember, intermolecular forces are bonds between molecules. This is going to be the hydrogen bond. And now finally, something important that I want to say is the fact that these bonds aren't kind of separate in the sense that these bonds build up onto each other. So for example, all molecules have London forces between them, right? But if you also have polar molecules, then they will have London forces and dipole-dipole forces. And if you have a molecule that has, or if you have multiple molecules that have hydrogen and nitrogen, oxygen, and fluoride bonded directly, then you will have London forces, dipole-dipole forces, and hydrogen bonds. So they build up on top of each other. Right. So I hope you enjoyed. I hope you have a better understanding of what these forces are. And just think of a couple of molecules that would have such bonds between them. Remember that these intermolecular forces are between molecules, so they're also between different types of molecules. They don't have to be between the same molecules, for example, like we have seen in dipole-induced dipole. So I hope you enjoyed, and keep learning, and see you next time.